this video, I will show you a curious experiment and you will learn various interesting procedure to compute and generate more interesting sequence from sequence of natural numbers, that is 1, 2, 3, 4, 5, 6 and so on. So let's come to the experiment. We should start our first experiment from natural numbers to generate the power sequence. We know the natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. So these are the natural numbers, and now we should delete the second term, each second term, and then we do compute the partial sum. Now we delete each second term. That means 1, next after deleting 2, 3, and then we delete 4 and we write 5. So in this way, after deleting every second term, we get the sequence 1, 3, 5, 7, 9, 11, 13. Next we have to compute the partial sum. Partial sum means next after doing partial sum we will get the sequence 1, then 1 plus 3 equal to 4, then 4 plus 5 equal to 9, then 9 plus 7 is 16, and then 16 plus 9 is 25, and then 25 plus 11 36, and then 36 plus 13 49. So in this way we compute for the partial sum of the sequence, and then we get the sequence 1, 4, 9, 16, 25, 36, 49. And very interesting, this sequence is, if you see clearly, then you see that the sequence is 1 square, 2 square, 3 square, 4 square, 5 square, and so on. We have deleted each second term first, and then after partial sum we get the sequence, a power sequence, that is square sequence. And now our second experiment, again from the natural numbers, and now we should delete every third term. Yes, each third term, we should delete each third term. Then we will get yes 1, 2, then delete 3, 4, 5, then delete 6, 7, 8, then delete 9, 10, 11, then delete 12, and so on, 13, after so on. So we will get this sequence 1, 2, 4, 5, 7, 8, 10, 11, 13. And now we should compute the partial sum of this sequence 1, 2, 4, 5, 7, 8, 10, 11, 13, etc. We will get this sequence like 1 and 1 plus 2 3, and then 3 plus 4 7, and then 7 plus 5 12, and then 12 plus 7 19, and then 19 plus 8 27, and then 27 plus 10 37, and then 37 plus 11 48, and then 48 plus 11 13 61, and so on. So now we get the sequence 1 3 7 12 19 27 37 48 61. So now we have to delete every second term, each second term of this sequence, because we have started deleting each third term. Now we have to delete each second term. That means we have to delete 3, and after 1 we will write 7, isn't it? Right? So we get the sequence like 1 7 19 37 61, and so on. So now we have to compute the partial sum, and then if we compute the partial sum, then what will we get? We will get like 1 and then 1 plus 7 8, and then 8 plus 19 27, and then 27 plus 37 64, and then 64 plus 61 125. So we get the sequence 1 8 27 64 125. So this the sequence is very much interesting, because the sequence is 1 cube, 2 cube, 3 cube, and 4 cube, and 5 cube, and so on. So I see if we start deleting each third term, and then we have got the sequence power 3 sequence, isn't it? So this is very interesting. Now we should go for our next experiment from natural number sequence, and now we should delete each fourth term from the natural number sequence, and then we will get sequence like this: 1 2 3, next delete 4, and 5 6 7, delete 8, 9 10 11, delete 12, and so on. So now we have deleted each fourth term. Now we have to do the partial sum, and what will we get? We get the sequence like 1 3 6 11 17 24 33 43 54 67. And so this is the sequence that we have computed the partial sum of the above sequence. And now we have to delete the third term. Next we have to delete the each third term of this sequence. That means 1 3 and delete 6, 11 17 and delete 24, 33 43 and delete 54, and next 67. So in this way. And now we have to do the partial sum, and if we compute the partial sum of the sequence 1 3 11 17 33 43 67, then we will get like this: 1 4 15 32 65 108 and 175, etc etc. So now we have to delete the each second term. Yes, each second term, and we get the sequence like 1 delete 4, then 15 delete 32, then 65, then delete 108, and we write 175. So in this way. So we have got the sequence 1 15 65 175. Now we have to compute the partial sum of this sequence, and if we compute the partial sum, then we get 1 and 1 plus 15 16, and 16 plus 65 equal to 81, and 81 plus 175 equal to 256. So we got the sequence 1 16 81 256, and this is very interesting sequence, because this sequence is nothing but a power 4 sequence. So see a very interesting pattern, that at the beginning we have started deleting each fourth term, isn't it? And then after deleting every after deleting every decreasing term, and then after partial sum we would reach the second term. We would reach to delete the second term, and then after partial sum we have got the sequence, the fourth power sequence. So it is very interesting that if we start deleting each fourth term, then we will get the power 4 sequence of natural numbers. That means 1 to the power 4, 2 to the power 4, 3 to the power 4, and so on. So this is very much interesting, and you will see that a pattern follows, isn't it? A pattern follows, and if this pattern follows, then we may get any power sequence from the natural numbers. So now we may review all the results that we have got from natural numbers. We have seen that when we delete each second term, then we get the sequence square sequence, that means power 2 sequence. And when from natural numbers, when we started deleting each third term, yes, first third term, and then after partial sum we have deleted each second term, and then partial sum, and then we have got the cubic sequence, the power 3 sequence, 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, etc. And then from natural numbers we have started from deleting each fourth term, and do partial sum, and then each third term and do partial sum, and then delete each second term and do partial sum, and then we have got the power 4 sequence. That means 1 to the power 4, 2 to the power 4, 3 to the power 4, 4 to the power 4. So following these results, following the pattern, we have predicted that if we started deleting each fifth term and do partial sum, and then we have to delete each fourth term and do partial sum, and then we have to delete each third term and compute the partial sum, and then we have to delete each second term and compute the partial sum, then we power 5 sequence. That means 1 to the power 5, 2 to the power 5, 3 to the power 5, 4 to the power 5, and so on, because we have started deleting each fifth term, isn't it? So we will get the power 5 sequence. So these are the pattern, and from the natural number sequence you will generate any power sequence. So we have come to the decision that from the natural number sequence, if we delete each kth term, here k means any big positive integer you imagine, and you want to that power sequence. So you want to generate that kth power sequence, then here k is any positive integer, and you have to delete first each kth term and compute partial sum, and then delete k minus 1th term and then partial sum. So in this way, if you continue this process, then you will reach a sequence where you have to delete each third term, and then after computing partial sum you have to delete each second term and then do partial sum, and then you will get the sequence 1 to the power k, 2 to the power k, 3 to the power k, 4 to the power k. That is the power k sequence. So this is very interesting. From natural number sequence you have learned to generate any power sequence, isn't it? So if this class appears or seems interest in your mind, then you subscribe the channel for the next class. So thank you all. That's all.